Hi, we continue, our lecture to this third clip, and we're gonna continue the detail from uh, at the end of the second clip that showed you last week, okay. Uh, so far we end up with the homework assignment for you last week for this work breakdown structure that appears the 18 activity of solving uh, this 3 by 3 system of linear equation, and we have developed deriving the block Gauss elimination and block back substitution, and then break it down to here. And also we left the homework is to write the work breakdown structure if you want to find the inverse of the matrix of A. But also we have giving you this Excel file, Google Sheet of the submatrix, right, of A11, A12, A13, A21, A22, A23, and A31, A32, and A33. Each of them have a size of 1000 by 1000, right? And then we also have a file, a copy of the matrix. This one is for 2 by 2, right? Solving linear equation, and this one is one matrix partition for the inverse of the 2 by 2 system. Okay, as an illustration of all in one, right? But these two files, we put all the submetrics in only one Excel file, but store in a different sheet. But then for this one, I just put the submetrics in each of these uh, separate Excel file or Google Sheet file. And then I have already load this file, simultaneously, 9 files all together here, if you can see, right? But in reality, you can just do it one by one, right? And then if you match this uh, for each spreadsheet file here, with the concept of this work breakdown structure of solving sub linear submatrices partitioning linear equation, right? Like this one, step one, you can start by the inverse of A11. You can go back to here, this A11. So this file you can, with the given of A11, you can find the A11 inverse, somewhere, maybe down here, using the concept that we uh, teach you earlier, right, in the previous clip, right? And we can go back to that step 2. We can find A12 prime is A11 inverse times A12, and you have A13 prime, A11 inverse times A13, which is the continuation of these two phi. You have A12, but since A11 inverse you would do it here, right? Oh, sorry, it's over here. I need to this one. A11 inverse is in this file, so you need to copy, right, the resulting of a 1000 by 1000 matrix of A11 inverse to this file. So Excel file to this A12, right? Maybe you can copy it and put it in somewhere here, right? After A12, somewhere here, and then the same size of 1000 by 1000, and then you can find A12 pi and put it in here, right? A12 pi here. The same as you can do the same thing for A13. You copy A11 inverse to this file, and then you compute by using metric multiplication of A11 inverse times A13, and put it in somewhere in the open space remaining, maybe here. Okay, 1000 by 1000. Okay, and you can go back. You can see that you can have A13 work by working this on the A11 file. This one you work on A12. This one work on A13. Okay, and you can create the separate file, okay, to work on B1, right? The new file, not beyond this 1 2 3 4 5, this 9 file, right? Something similar that you if you remember, when we put all of this in just one uh, file with different sheet, right? You can have additional sheet to compute this B1, okay, and then you can have you can copy A12 file from A12 file from A12 file here, and then you can copy A21, okay, or maybe you can use A21 in the file of A21 here, okay, sorry, this one A21, yeah, here, right? You can go back here, you can compute A21 times A12 prime, okay, and then you can subtract it on the file of A22, right? A22 here, right? And then the same thing you can do for A23, right? You can go to A13 file, right? And then copy A13, okay, and then you can use to this A21 times A13 file, okay, and you can work this on the file of A21. A21 over here, you can have this two metric multiplication file by putting A12 palm from A12 file here and A13 palm from the file A13. And then you can update the A23 palm and A22 palm in their own file, right? And then certainly the next step was you can use copy A21 and use B1 palm, okay, from the different file beyond this 9 file, separate file, right, to compute B2. And so on. You can go to the file of A32 over here, okay, A32, okay, and you can certainly use this product of A31 times A12 file and A31 pi A13 palm, okay, by putting this two metric multiplication in somewhere in the file of A31. Sorry, yeah, over here, A31, right? And then after you get that result, okay, you copy it to the file of A32 and A33, and then you can use this metric subtraction, and then you get A23 and A33 palm. Okay, so and also, right, you can do the another file of the 10 file additional file to compute B3 palm. Yeah, right. And then with the A22 over here, right, A22 palm, in the same file you can compute the A22 palm inverse, right? And then you can use that inverse, copy and update with the A23 palm, A23 double palm, and B2 double palm, and then keep on going until you get the X3, X2, and X1, right? So that's an the key assignment from our lecture last time, that I want you to implement this workflow of computation to a different Excel file. Instead of we trying to do the same thing that we did previously, like in the 2x2 case, that we put everything in just one file, and you can see that the file keep getting larger and larger, right? And then sometimes make it so difficult, and it's not save the memory, because when you open the file, it's like you open the whole metric uh, simultaneously. But in this one, if you keep working one file at a time, right, the other file will be stored on the secondary storage, and then you can save more memory, and then the extension of the submetric can be handled in the larger scale, right? So this is where we were, right? From last time, okay. Uh, Here, right? We end up here, and then we extend you to think about the inverse of the how do you write the weight breakdown structure of inverse of A. And if you be able to do this homework, okay, the next step is also that you can go ahead and work on this submetric of 3 by 3, right? But if you look at the lecture, the link of the lecture, this is the solution have been already established from the sheet of lecture sheet from 10, 11, 12, 13, 14, and 15, right? So we're gonna talk a little bit about this, okay? Okay, you start here, okay? Okay, the problem start here. Write the work breakdown structure for the inverse of the matrix A when each of A sub I j, okay, of the submatrices it belong to the size of ni times nj, ni by nj, and n sub 1 percent sub 2 percent sub 3 is equal to the 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 overall n, right? And then if you using this extended the approach that we did earlier in case of 2 by 2, this is also we can be extend for 3 by 3, right? For we start with the A matrix on the left side, and then you add, right, some identity matrix, okay, yeah, right, try to embed the identity matrix, okay, to the original matrix on the right side, right? And I can have this small partition illustrate for you. And then we start the block elimination. The block elimination trying to change the original matrix on your left side here, right, to become just like the right size. And then with the transformation using block Gauss elimination, the resulting of the right hand side, the right matrix here, on the right side here, become the inverse of the A. Okay, so block elimination start with what? We're gonna trying to do this to become I1. Which I1 is the identity matrix of the side n sub 1 by n sub 1. So the easiest way is that we multiply the first row of this submatrices by A11 inverse. A11 inverse times A11 become I1. And then A12 palm is A11 inverse times A12. And this one A11 multiply inverse multiply here. A11 inverse also multiply here. You become A13 palm. This one become A12 and A13 palm is A11 inverse times A13. And A11 inverse times I1 become their own A11 inverse. And this one is 0, 0, so they remain 0, 0. The next step, we're trying to make A21, eliminate A21 to become 0 submatrices. And A31 by block elimination to make this 0 submatrices. So with A21, okay, to make this a 0 matrices, easiest way is we use A21 multiply this the row of this row, okay, of submatrices, and then subtract from being subtracted from the original row here, the second row submatrices over here. So when A21 multiply this corresponding row, A21 multiply I1 become A21, and then you subtract from the original value of A21, you get the 0 matrix. But for A22, since A21 need to multiply to A12 prime, A21 times A12 prime, and then subtract to the submatrices of the original A22. So this one become A22 palm. This one is equal to A22 minus A21 times A12 palm. Similarly for A23, A23 palm become the original A23 minus what? A21 times A13 palm over here, right? You get here. And then you can see that when A21 multiplied by A11 inverse here, and then subtract it to the original 0, it becomes this value. If you have A21 times A11 inverse, and then you add the subtract sign over here, minus, and you call this a C sub 1. So this one is the what A21 over here multiplied by A11 inverse and subtract to the original 0 value, become minus C sub 1. C sub 1 is a submetric resulting here, right? The same for A22 palm, A23 palm, and C1. You can get A32 palm, A33 palm, and C2, right? Over here, like A32 palm over here is you want to eliminate A31, right? So you multiply A31 to this row, this corresponding row, right? Sometimes you can you can refer this as a pivot row, right? And A31 times I1, and then subtract to the A31 becomes 0 metric. And A31 multiplied by A12 palm, subtract to A32 become A32 palm. And A31 multiplied by A13 palm and subtracted from A33 become A33 palm, right? So this one you get A32 palm and A33 palm. The same as over here that you have A31 multiplied by A11 inverse and then subtract to the 0 element here, submatrix A. So you get minus C sub 2, right? Where C sub 2 is A31 times A11 inverse. So this is the first step of block elimination. We make the first column of submatrices right over here to become similar to this column, right? Additional column of the identity to the original A matrix, right? So the next step is trying to make this second submatrix column to be 0, I2, and 0. Okay, and this is what we do. We're going to refer to this notation after this, and then next step you can get this. Why I can make this and this one become A13 double pi, the new A13, the new A23 double pi, and then the new A33 double pi. The easiest way to explain this is you want to make this an I2, right? The identity of size of n2 n sub 2 by n sub 2. So you get A sub 2 palm inverse multiply everything in this corresponding row submatrices. So A22 palm inverse times A22 palm become I2, right? And A23 palm become A22 palm inverse times A23 palm. This one is A23 palm, you get A22 inverse, multiply this become A23 palm. And C5, okay, instead of this one I need to add the sign minus. I want to make it like eliminate all the minus sign, not to confuse me, so I add the minus sign immediately over here. So the C5 become A22 inverse, okay, multiply the original value, which is C sub 1. C sub 1 is over here, right? So if you have minus C sub 1 multiply A22 palm inverse, so become C sub 5, okay. And then the last element is that this I2, you get A22 palm inverse multiplied by I2 become A22 palm inverse, and this is 0. So this one become the pivot row, right, that we're going to use during the elimination, right? And then this one we already make the second row submatrices first, And then we can eliminate this element to become 0 very easily. That you go back here, you already make this I, so you use A32 palm, right? Multiply A32 palm, multiply this row, right? This submatrix row, and subtract to the original value, okay, location by location. So when A32 palm multiplied by I2 and then subtracted from A32 palm, so this one become 0, right? And A33 palm become A32 palm over here, you remember that? Multiplied by A33 palm, this become over here A33 palm over here. A33 palm, the original A33 palm over here, minus A32 palm time A23 double palm, right? This one you have to make this an I2 over here, right? So this one is A33 palm minus A32 palm, A23 double palm, right? And then the same is that this one becomes C6 is C6 is become, you can see that why C6 become minus C2, because the original value is minus C2, C sub 2, okay, minus C sub 2, and then you need to subtract it, uh, this value A32 multiply every element in this corresponding submatrix row. So it's going to be A32 palm times C5 over here, minus, and this original is minus C2, and then minus this. This becomes C sub 6, okay. And what about C sub 7? C sub 7, the original value is, you can see that the original value is, C sub 7 is over here. The original value is 0, right? So it was just subtraction of A32 palm times A22 palm inverse, this one, right? This one, sorry, C sub 7 minus A32 palm, okay, times A22 palm inverse, okay, over here, A32 palm multiply here, and then the original is 0, so 0 minus this becomes C sub 7, right? So this one you get this elimination for this. The same thing, we can eliminate the first, this element. This element, the original value is A12 palm, so you can use A12 palm, multiply every element in this row, same location, and subtract it back to the original value over here, right? So A12 palm, when they multiply by 0, nothing. So the original value still keep the I1, okay, over here. This one is I. But for this one, you get A12 palm times I2 become A12 palm, and then subtract it from the original A12 palm. So this one become 0. And A13 palm, you get A12 palm over here multiplied by A23 double palm, and then subtract to the O value of A13, which is A13 palm. So this one A13 double palm is A13 palm, previous one, minus A12 palm over here multiplied by A23 double palm. Okay, and you get C3 and C4, right? C3, you can see the original value of C3 is A11 inverse over here, right? So you get A11 inverse minus, you get A12 palm multiplied by C5, okay, and then subtract to this one. The original value is minus C2, this one minus C3 is over here. The original value is A11 inverse, okay, minus A12 palm over here, and then multiply this row, this one, and multiply C sub 5, okay, and then subtracted from A11 inverse. So this one is C sub 3, okay, and then C sub 4, okay, C sub 4, you have A12 palm over here, right, and then you use this, multiply this one, right, so this one will become A32 Okay, this one is C4, sorry, C4, you can see that. It become A12 prime times A22 prime inverse, and then since it's subtracted from the original value is 0. So this one become minus, minus A12 prime times A22 inverse over here, subtracted 0. So you get the minus value here. So this one is C sub 4. And then you know that this one becomes 0 because A12 times this is 0. The original value here is 0, right? So now I already explained the flow of computing that it's pretty close to get the final value over here, right? Because now we already make these two submatrices column similar to here. So the final step is try to make the third column here similar to here and happen to this location. Okay, so try to make this 0, 0, and I3. So the remaining part here, even in the submatrix form, become the inverse of the whole matrix A. Okay, and that's what we did. We used this notation to carry on to the final step, right? The final step, suppose that I call this B sub 1, 1, B sub 1, 2, B sub 1, 3, B 2, 1, B 2, 2, B 2, 3, B sub 3, 1, B sub 3, 2, and B sub 3, 3. So you're going to get this as the inverse. Okay, the whole metric partitioning 3 by 3 here, right? And again, you try to make this an I3 from this original value. Very easy, that we just use A33 double pi inverse, multiply to every element, okay, belong to this submatrix row. A33 double pi inverse times A33 double pi become I3, right? And it's easy to see that B31 since this is a B33 over here, the easiest one is that because this one is I3, since you get A1 or A33 double pi inverse, multiply everything. So at I3, which is the partition part of B33, so the first one you'll be able to identify is B33. B sub 33 here is A3 sub 33 double pi inverse. Okay, and once you get this, certainly you get B31 and B32 very easy, because the origin value of this is C6, C7. You make this as you get A33 double pi inverse, multiply to C sub 6, is become here, and multiply to C sub 7, it become here, and that become B31 and B32. You see that B31 and B32, right? Okay. So this one you get these three submatrices at B sub 3 1 and B sub 3 2 and B sub 3 3 first. Okay, this one 3 3 3 1 3 2. The next step is that we can get this B13 B23, okay, very easily, because if you look at when we're trying to eliminate these two elements become 0, you go back to the origin over here. We're trying to eliminate this 0. You're going to use A23 double pi and A13 double pi to multiply this corresponding row, sub-matrices row, 0, 0, I3, B3, 1, B3, 2, B2, 3. So to eliminate this to become 0, you're using A23 double pi, multiply this. Once A23 double pi multiply this, okay, you easily get B23, because at B2, the original value this is 0 is 0. So there's no original value here, because it's a 0 element. So you can write B23 and B13 immediately, that, okay, B13 belong to this pivot element that you try to eliminate this one. The original value for this is A13 double pi. So B13 is A13 double pi times B33. A13 double pi times this one, and then after that, since the original value this is 0, so you get a 0 submatrix minus A13 double pi times B33. the same as for B23. Since the original value is over here is 0 also. So you get B minus A23 double prime times B23, A23 over here, the original value, multiply A23, and then subtract to the original 0 value, you get this subtraction. Okay, so you get B13, B23, so all this you get there. So the remaining this 4 element, okay, you just followed what the elimination process do, right? B11, okay, over here, since this is the elimination element, the original value is A13 double prime, so you get A13 double prime times over here, this pivot low now become A13 double prime times B31, right, this one, and then minus to the original value here. The original value here is C sub 3. So this one becomes C sub 3 minus B, that's B1. B12 become, right, the original value is C sub 4. So B12 is the original B sub 4. And then you eliminate this to 0, you're using A13 double prime here to multiply this and this value, right? So the A13 double prime need to multiply B32, right? And then subtract to the original value, which is C sub 4. So this one B12. And then you can get B21 similarly, right? But now your eliminated submatrices is A23 double prime over here. A23 double prime. So it becomes A23 double prime times B31 and subtract that from the original value of B21. The original value is C5. So this one you get C5, B21 you get C5 minus A23 double prime times B31. And the final one is B22. B22 become, you get the original value of B22, you can see here is A22 prime inverse, right? Now you get B22, A11, A22 prime inverse, the original value, subtracted from this one, the original, the eliminated element is A23 double prime, you get A23 double prime times B32, right? And then subtract that to the original value, which is A22 prime inverse, right? So now you already finished the block elimination process, right? And then you can get from the original idea of finding the inverse metric, especially for n by n scale, any n by n scale. This sub-partitioning of Bij sub by j or with n with the size of ni by nj, okay, n sub I by n sub j. I always forgot the sub to say in full, okay. So with this explanation, okay, of the computation process, we can summarize and do something similar to what we did before here. This one is 2 by 2 system for inverse. This one is solving the 3 by 3 linear equation. Okay, and after this, you can develop the work breakdown structure of the 3 by 3 inverse matrix, which is actually the question, the homework that we left for you last time. Okay, now we go to this. We start with A11 inverse. Actually, we go back and start following this step by step. You start from A11 inverse, and then you get A12 prime, A13 prime, C1, and follow step by step, and then you get, after that, you compute this, and then you compute the end results of B sub 11 until B sub 33. You can see that this is a flow of computation with the predecessor element, right? Like the first job you need to do actually to find A11 inverse, right? And if you go back to the Excel file, you know, it's something similar we did with 2 by 2 system, that the A11 here, you need to find the inverse first, right? And then you go here, you can go to A125 over here. No, sorry, I always make a mistake. A125 here. This is A125. You can compute using the value of A11 inverse from A115, copy to A125, and then use metric multiplication to get A12 prime. And you can get A13 prime from the phi of no, this one from phi of A11 inverse and the original A13, right? And then you can have a separate phi, right, to compute C sub 1 and C sub 2. Or maybe you can use that C sub 1 and C sub 2 is a phi of A21 and A31 by copy of A11 inverse from this phi. And then you can compute C1 and C1 is a part in the phi of A21, C2 is a part of the phi of A31. And then after that, okay, you can compute this one also, maybe update another file on the file of A21 by using A21 time and copy the value of A12 prime here, which is the second job you need to finish, and then find this product before. And then at the file of A22, you can use the matrix subtraction formula. Actually, it's just a copy and paste. And then you can find the A22 pi inverse, right? And also you can update A32, A23, and A33 along this file separately, right? Oop. Oh, okay. The next step is over here. I miscount it. Okay, I need to correct that the renumber this again. Like this one 6 and move to 8 that he has 7, 8, 9. And then you can activity 10. You need to compute A22 pi inverse to carry on to come A23 double pi. Actually, everything that I wrote in this work breakdown structure, just follow the step-by-step of computation that we developed over here. And I did explain to you previously. Okay, so it reached toward the end, right? When once you get A33 prime inverse, which is B33, and you get B31, and then you get B32, and so on. Okay, so now you can have nine different files to keep. This is the input file. Oh no, sorry. This is the input file, Excel file, 9 file of Aij of 3 by 3. And with this forward formula, you can create the results of 9 file 1, keep Bij, B11, B12, B until B33, right? And but you cannot do this immediately. You have to follow the flow of what we call the predecessor constraint. Predecessor is mean that you can't perform this task unless this previous task has been finished before. You can get the results and copy those results and work out on the different worksheet file. Okay, so you can see that after I wrote this, okay, I can extend this toward a 4 by 4, right? You remember if you want to do 5 by 5, and so maybe for n by n and so on. Okay, but unless you're facing that situation that you need to partition a very large, let's just say very large scale dense matrix. Okay, so and for small sub metric that your computer can work on, just like what I keep telling you so far, that we start with the size of 10,000 by 1,000 on Excel, because we already experiment that it is still workable, right, on the worksheet. But then with the 2 by 2 case, you can see that if we put together everything into one worksheet, it's gonna cause the file to become getting larger and larger and reaching the critical state of execution that sometimes they might reach the out of call, and they're not gonna call out of call. Let's just say that even though you have sufficient amount of memory, but the response of the computation getting worse, getting slow, right? Because it occupies too much memory, right? So again, in this one, okay, since you already have this file that I gave you, right, in the Google Sheet separately, this one, 1, 2, 3, A112, A33, the submatrices of A33. Okay, so you can continue to work, okay, uh, to do your work on the 3 by 3 inverse. Okay, apply that to find the inverse matrix according to the flow of work over here. And then the end result that I expected, you can have Bij, okay, the 9 different submatrix Y, each have the size of 1000 by 1000, because the submatrix is, oh no, sorry, the submatrix is over here size of 1000 by 1000. So when you work on the 3 by 3 system, it means that the original size of the dense metric, we work on 3000 by 3000. But this one is extended because in 3 by 3 linear equation that we explained previously, it take only 18 sub-activities. But for inverse, right, which certainly the results require more memory, right, and it becomes 27 activity. If you are interested, you can keep continuing. You are deriving this flow of computation with maybe like 4 by 4, 5 by 5, so on, right? Okay. This is a extension of the original idea to find the inverse matrix of size. Uh, Now 2 by 2, we already illustrated for you. 3 by 3, I didn't do any Excel for you, but I just hope that my illustration of 2 by 2 give you a clear idea to extend and apply for the 3 by 3 here. Okay. But is this the only way to find a 3 by 3 matrix, inverse matrix here? Okay, I'm just using generative AI for fun. Okay, before after I did prepare this lecture, okay, I did ask uh, Gemini, right, the new generative AI competing with the ChatGPT, right, and they did not recommend me to work like this. So this one is my the resulting of my work preparation previously, not using not asking the generative AI. So after this I show you some alternative. Actually, this page of 2 by 2 is not new. It's a thing that we did before, right? Change this to and change this size, the left side here, to become 2 by 2 of I1, I sub 2, and the 0, 0. So the the embedded additional submatrices over here, B11, B12, become the A inverse. And with this is the exact what we did last time, in the last script for the 2 by 2 system. And but the key question is that, can we extend this idea? That's what Gemini told me. Okay, Gemini told me that actually you don't need to relive this again and again. This one 3 by 3 and 4 by 4. Do we need to start this again? Okay, we need to continue. Okay, working on the 4 by 4 case and 5 by 5, 6 by 6. But what Gemini told me, okay, I didn't keep the results show on the screen. I didn't save it, but I just very exciting to me that they say that just this concept is already enough. You might found that, what, this is 2 by 2, but this you just say that 3 by 3 you extend from 18 activity to 27 activity. But you have something similar, right? In the first step to 2 by 2. 2 by 2 is sometimes is a sub part of 3 by 3, where if you're using this analysis. But Gemini tell that, okay, just this formula is enough. This formula is the original for 2 by 2, which already explained it in full detail for you in the previous clip. Now we're going to apply this concept for the 3 by 3. Okay, so you can look at here. This is the way that we apply that. Suppose you have a 3 by 3 system over here. Okay, we're gonna integrate some part of 3 by 3 and make it a 2 by 2. Like this one, we're gonna integrate A11, A12, A21, A22 all together, and we're gonna call this submatrices A11 star. And this part will be A12 star, right? It consists of A13 and then continue in row, not column, right? By A23. And then continue in column with A31 and A32. Integrate this and you call this A21 star, and this one A22 star. It is the only one that still remaining like the original one is A22 star, which is the exact A33 in both size and values. So with this new partitioning, right, I already reduced the 3 by 3 system to a 2 by 2 system, which we already have a formula to work here, right? So that's what Gemini told me, right? When I asked them the generative AI of Gemini. So once you know this become B, this one. So we can also apply this formula, right? So the first step is that you need to find A11 star inverse first. Remember that, this one? If you have this, the first thing you need to do, you need to find A11 inverse. Again, you need to find A11 star inverse. But A11 star inverse is a 2 by 2 system, which you already have this formula to find the inverse in the partition form. So this 2 by 2 system, to find the inverse, I can apply B11, B12, B21, B22 exactly the same as what we did compute here. B11, B12, B21, B22. Exactly the same here. We can find A11 star inverse. Okay? But with this one, you have 2 by 2. With this, let's change the notation become A11 star, A12 star, A21 star, and A22 star. So to find this one, A12 palm equal A11 inverse times A12. So you can see this one is become A11 star inverse times A12 star if you work on this notation. But you know that A12 star over here consists of these two submatrices of A13 and A23. And A11 inverse, okay, is already here. You have this partition computation from here. You get B11, B12, B21, B22. So you can use submatrices, matrix metric with submatrices and do the metric multiplication. So this one will become this one multiplied to A12 star. A11 star inverse times A12 star. And exactly the same, you can use the rules of the inverse, right? This one become B11 times A13 plus B12 times A23 with this metric multiplication. And the second element over here become B21 times A13 plus B22 times A23. Okay, I'm gonna call the first part over here become A13 part, and this one A23 part, right? And this one we call A12 star part. Okay, so our A12 star part consists of these two submatrices. Okay, And then you can see that based on here we need to find A22 palm here. So this one become A22 star palm. A22 star palm will be equal to A22 star, which is A33. A22 star is A33 minus this one A21 palm, okay, multiplied by A12 palm, because you already convert this, you remember that? You convert this to become I1. So this one become A11 inverse over here and A12 palm. Okay, so once you try to eliminate this one, right, and then during the process you get A22 palm become the original A22 star, A22 star palm, the original value is A33 minus this one, the elimination plot become A21 star times this one, but this one become A12 star palm because you want to make this as an identity matrix first. So this one, and then you can substitute A21 star over here. A21 star is A31 and A32, okay, this one, and A12 star palm is over here. We already told that this one is A13 star palm and A23 palm. So based on the matrix multiplication, A22 star palm will be equal to A33 minus A31 times A13, and then minus another A32 times A23 palm. Over here you get A22 palm, and now you can go back and get all the results here. You get B22 become A22 palm inverse, and this one you come B22 star over here, or B22 star become A22 palm inverse, which is this matrix inverse, and then B21 based on this formula, B2 or B12. B12 is A12 palm, B22, right? This one we got B21 first. Okay, after we get B22, B21 is minus B22. This one you already compute, and you need to multiply A21 and multiply A11 palm. So let's see how we do this substitution. B22 palm is already fine here, alright? So, but A21 star is this one. It become A31 and A32. And then A11 star inverse. A11 star inverse already partitioned in B sub 1, B sub 1, 2, B sub 2, 1, and B sub 2, 2. So with matrix multiplication, it's obvious that you can get B21 star as, okay, the first part, you get B22 star, right, minus B22 star, and then the first element is A31 times B11 plus A32 times B21. And the second part, you can see that B21 over here consists size of a, since these two partition into two parts, okay, and with the same row, and the column just continue to each other, right? So B21 also have two parts also, right? This one based on the matrix multiplication, and each of them summation multiplied by minus B22 star. Okay, so you get this B21 star, and then B12 star is minus, based on this formula, this one minus this one minus A12 palm times B22. So you get this minus A12 palm, this, because A12 palm we already found here, we already identified this as A13 palm and A23 palm. So you get A13 palm, A23 palm, and multiply by B22 star. So this one is very easy because you get this multiplied by this, and this one multiplied by this, and you get this two submatrices continue in row instead of column, right? Which is similar to what A12 star is. B12 star also have a similar partitioning, matrix partitioning over here. And the most time consuming will be B11 star. Okay, B11 star is A11 star, this is the original value, this one, A11 star, and minus A12 palm and B21. But you all know that A11 star, in this one, A11 star here is already B11, B12, B21. And A12 palm, okay, is already here, just like we did, sorry. Oh, hold on for a few seconds. Okay. Where is it? Okay. You see. Okay. This one. A13 palm, A23 palm is over here. A13, which is A12 star palm, based on this one. And B21. And B21, okay, you can see that is here. Right. So you need to place this B21 over here. This one is B21. Two submatrices. Right. This one. And this one is A12 palm. And then you get this 4 submatrix, just like what we find the matrix partitioning of A11 star. So the B11 have the same star here, has the same partitioning in the inverse matrix based on the extension of here. Like this one is, you can see that once you metric multiplication, it becomes this time this, this time this, this time this, and this time this. And location by location, you add it up to the original value. Like B11, the original here is B11 plus this one, it multiply this A13 palm times B22 palm times this summation of these two metric multiplication become the first element here of B11, right? And B12, B121, B22, similar fashion. Okay, so this is what Gemini, okay, tell me if you want to find this metric partitioning of the 3 by 3, right? And the idea of Gemini that generative AI recommend me uh, gave me a wondering comparison study that which become the homework, another homework for this clip, okay, for you to work on that. Okay, since we already did fully work breakdown structure by using the direct method here, right? And we break down to 27 steps, right? But this one is another approach, okay? 3 by 3 is the same, right? But this one is just a mathematical flow, okay? But it's not the work breakdown flow, structure flow, okay? And we didn't count the number of operation of submatrices. So one of the homework that you can do, okay, based on another homework, okay, based on the lecture of this clip is that can you from this one from sheet number 17 and 18 over here, can you develop some work breakdown structure similar to this on sheet 13, 14, and 15, and then compare the amount of computation. Compare the amount of computation. And which approach do you think? That the original one that I prepare for you and explain to you firstly, or the one that Gemini generative AI recommend me to do? Okay, and also you can apply on both approach here. Okay, realize that this one is a compelling in terms of mathematical sense, but computational sense, you all remember that you already have this file to work on. The submatrices of 3 by 3, right, to work and compare, right? It's the same, the two approach, right? One is here, already established 27 step, and but this one we haven't break down that how many steps you need to compute. And but we have the test problem of the size 3000 by 3000 where each submatrix is 1000 by 1000, keep in the separate file over here. Okay, so this one you can do both written comparison of by analyze mathematical term and comparing, and also you can realize it by applying those two workflow, okay, for this data set that I have given you, right, in the link of the Google Sheet. So many homework already, right, from this clip. In addition to the previous assignment from the last clip, right? And you can do that. Moreover, okay, sorry, I also extended for 4 by 4 here, inverse of 4 by 4. So each part of this become a 2 by 2, right? Become a 2 by 2. I think that it just apply the same idea that if we keep devise the partitioning of 4 by 4 and make it a 2 by 2 instead, right? And then you can apply the formula of 2 by 2, right? And then by substituting each part for the smaller submatrices and then derive with the new formula here. So this worksheet is an additional for you that you can keep expanding to 5 by 5 sequence and so on. So this one is that, and it serves what Gemini say that for the size, any size larger than 2, the thing that you need is this one, this sheet number 60. The 2 by 2 is already enough. If you keep expanding for 3 by 3, this one, these two, sheet 17 and 18 show. If you expand for 4 by 4, here, over here, 4 by 4 is, you can see that once you get this to B11 become another submatrix of 2 by 2 for each B11, B12, B21, and B22. So you can apply the direct 2 by 2, right? Once you change the size of 4 by 4 to 2 by 2. And then for each part of computation, you can directly apply the submatrices within the submatrices to expand the formula over here. Like here is that one is that is the first step you need to do, right? Because you need to find A11 inverse, A11 star inverse, A11 star inverse. You can apply directly of 2 by 2, the original 2 by 2 formula. So the one you need to find first, and once you can find first, you can find B21, B22. Okay, this is the second step. Okay, once you find this one, A12 palm, right? This one A12 palm and A22 palm. Okay, once you get A12 palm and A22 palm, right? And then you can, I write to you that this part will become this one A12 palm is B, another partitioning metric 1, right? Over here. And this is the third step, okay, of finding A22 palm. Okay, by using this one is just a reassign the new value, right? Because you want to find, once you get A12 palm and A22 star palm over here, this is the exact formula we did, but we need to expand. Since A11 star inverse become here and A12 star here, it become here. So the A12 palm, okay, also have a partitioning metric of B11 palm, B12 palm, B21 palm, B22 palm. And the same for A22 palm over here. Okay, you can have this. I think in this one we didn't really complete the inverse, okay, of finding B11 star, B12 star, and B21 and B33 star. But we did compute. You can see that A12 star, A22 star, because to get, if you remember the formula here, You need to find A12 star, A22. If you know A22 palm, you find A22 palm inverse, you become B22. And then after that, you can apply this to find the computation for each part of B11 star, B12 star, B23 one star, B21 star, and B22 star on after this. Okay. So this one also you can continue to work. Okay. And this is what we did. I already did it for you, right? This one is a step. Okay. After you get A2. So it's start the result step. This 1, 2, 3, and then you compute this, the fourth part, fifth part, sixth part, and then you get seventh part. You can see that you start having the results of B22 here. This one B22 become over here, the 4 submatrices, and B21 another 4, and B12 star, and then finally B11 star. Okay. Again, this one haven't finished the workflow structure, work breakdown structure flow. Okay, if you want more challenging, I I say that it's gonna take you more than, let's say, you might guess can be up to 40 sub activity to finish all of this. Okay, so but based on our numerical data, didn't we didn't we we didn't give you the sub matrices of 4 by 4. Okay, we only given the data for 2 by 2, right, and 3 by 3. Okay, if you want, don't let me stop your imagination, the never ending. If you interested on this 4 by 4 and the size of 1000 by 1000, so it become 4000 by 4000 to solve. Don't let me stop you. Okay, you can keep create the problem on your own, create the sub matrices so that you have 16 files, and then if you be able to analyze this, or at the same time, this is a benchmarking of this 4 by 4. uh, I did go to this, okay, for 4 by 4 according to what Gemini recommend me to go, right? But actually you need to answer this question first, right? That we don't really know whether the idea that Gemini recommend me to do this, by keep using the formula of 2 by 2 and expand to the size 3 by 3, 4 by 4. Is it better than the direct analysis that we are doing here, right? So you need to use the 3 by 2 case to analyze and then to see, to compare both approach. Maybe you might find that it is worth to expand this approach for 4 by 4 instead of trying to go along with what Gemini say recommend to you. I can't really tell you unless you work on your own and then trying to explore all the result possibility. Okay, so we now, okay, I think finishing our lecture for the Excel part, okay, and also I already recommend you the additional work that you can work on this 9 separate of 3 to you can start the 4 5 2 by 2 and 3 by 3 with many approach of finding solving a linear equation, right, and also finding the inverse of a large and dense matrix with size of you might try to use the 1000 by 1000 of the submatrices, and then you expand to 2000, 3000, and with the partitioning approach that we apply, we can keep growing the size of the matrix until your machine not responding, right, or do have a very poor response. Okay, so but and also you can work on a lot of problem on the Excel corresponding Excel file that I assign to you. Okay, In the next clip, we will change the platform of computation. Okay, we'll be using a platform, what we call a commercial and a very powerful software called MATLAB. Okay, over here, you click into the subdirectory of MATLAB. You see that I show you many of the results and also the coding. Okay, so we're gonna restart uh, what we have done so far, but we move from uh, the platform of Excel to MATLAB. And I'll show you that the efficiency is much more increasing as compared to the Excel, right? And also it can be used to prove, okay, whether you get the correct solution in an easier way, okay, and as compared to using the direct solver. I think one thing that I have to remind you that all the work that I recommend you to or assign to you to work on uh, in many part that I in the lecture of this clip, okay, I make sure that once you finish it, you have to prove it. Like if you're solving equation, you need to balance it, whether what's the difference between the left hand side evaluation once you get to know all the value of x, right? You need to multiply a times x and whether it's equal to the right hand side b or not. And also for the inverse matrix, after you get the sub part of the sub matrices of the resulting inverse matrix, okay, you need to using the A times A inverse and check whether it's equal to the identity matrix or not to make sure that you get the correct results. Okay, so but in the MATLAB, in the next script, you will see that MATLAB is much more efficient and you can expand that the size, the comfortable size of the sub matrices, right? In the case that I will show you that you can see that we can expand from the size of 1000 by 1000 in Excel to 10,000 by 10,000 in MATLAB using my machine over here. And my machine at home capable around 10,000 by 10,000. It's the comfort zone of execution. But if I'm using the same file for at the computer in my office, okay, which is more efficient, the comfortable zone can be increasing to 15,000, right, which is very large. Like for example, if you have instead of you have size of 1,000, 2,000, 3,000, I can if I use MATLAB, I can have a large dense system of size 20,000, 30,000, 40,000, 50,000. So okay, hope you follow. Okay, go back and review all the detail that I already covered. Okay, and see you in the next script with a new platform. Okay, and make sure that you install the MATLAB also because if you're using your Gmail code, okay, to enter the installation process, you should not have any problem of installing the latest version of the MATLAB because university is pay pay them annually, okay, to become under the university license. Okay, I think that you can check out, okay, through installation of MATLAB to the website of engineering, like engineer. Okay, sorry. I'm gonna show you engineering.ku.th over here. Sorry for those of you who are not familiar with the Thai. Actually, they have English version over here, but I'm not sure the English version have the link to the MATLAB. Okay, I'm not sure where did they put it. Maybe here. You look at here. We call in this work function. Actually, this one in Thai, but In English, we call this an information system. Okay, and then once you get this, you go to here, over here, double click here. Okay, first you click here, and then you go to the sub menu or under the same name. You get to get this. Okay, actually this two is the same. That you can see that with this top, this one is a lecturer, this one is a student. Okay, yeah. And you can see that there's no MATLAB for this personnel, that they didn't need this. But for the lecturer and for the student, over here you have a sub menu called MATLAB. You can install the MATLAB on your computer through this process. Okay, if you press MATLAB, okay, this one. If you click over here, you call MATLAB Campus Wide License. Okay, this is what is free. This one was free under the account that you have at ku.th, the Gmail, right? Normally. Okay, if you click over here, you go to the installation process, and by using this account that you have as a student, you should not have problem to install your the MATLAB into your computer. Okay, so see you in the next clip. Okay, and we're going to move to this highly efficient computational platform. Okay, I think I have to stop here. Okay, see you.